Alright, we've reached the final video of the quarter. Yippee! This final lecture is just a brief overview of a microprocessor, just looking at some of the hardware of what makes up a microprocessor. Here's a diagram where everything you see inside the dash box, when that circuitry is on a single chip, it's called a microprocessor IC. And most of what's inside a microprocessor are registers that have specific tasks that they were designed to perform. Okay, so much of, if not all of, the digital circuitry that we've talked about in the second half of this course is all located in this single chip. Now, you may wonder, because I'm sure you've heard the term microcontroller and also microcomputer along with microprocessor, so you may wonder what the differences between those are. Well, as I mentioned just a moment ago, if all the circuitry within this dash box is in a single IC package, that's called a microprocessor IC. However, if in addition to what's inside this dash box, you also have some memory in that same IC package, then it's called a microcomputer. So a microcomputer just has what's called onboard memory, which is memory in addition to the microprocessor circuitry, all in the same chip. And then a microcontroller is the same as a microcomputer, where most of that memory is used for input-output data, which are called ports. Okay, so the only real difference between the microcomputer and microcontroller is how the memory is being used, at least the majority of it. Alright, now there's a handout on PolyLearn that I made that talks about each of the hardware components inside a microprocessor in some detail. I'm not going to read this to you or spend all this time of this video on these details. What I want to spend some time on is just a main part of the microprocessor where the instruction is interpreted and then carried out. And where that takes place, and really one of the main, if not the main component of a microprocessor, is called the TNC, which stands for timing and control. It's an N, control. So look, there's two inputs to the timing and control. One, the IR, this is the instruction register. So this is where the instruction that the microprocessor is going to carry out is located. This is internal. This IR is internal to the microprocessor. See, it's right here. The instruction typically will come from memory of the computer, so it comes through what's called the CPU bus, and then inside the microprocessor, and the instruction is stored there. So the instruction originates most often in memory, is brought into the microprocessor through the CPU bus, and is stored in this register, which is just a memory register that has the specific tasks to store the next instruction that's going to be executed by the microprocessor. So that instruction will be here until it's executed, and then it's replaced with the next instruction out of memory. Okay, so that's one input into the TNC. The other input is just a periodic clock, a CPU, or a periodic square wave, which is your CPU clock. Right, so when you buy a computer and they tell you it's a 2 gigahertz computer, that's the 2 gigahertz is this, or the 2 gigahertz would be the frequency of this periodic square wave that's inputted to the TNC along with the instruction. And then the output of the TNC goes to various hardware components in the microprocessor, which again you can read about to see what their specific functions are, but I've listed a few up here. But it basically goes to all the other hardware devices, components that are located inside the microprocessor. Alright, well, there's two really important things that the TNC accomplishes. Okay, the first thing the TNC does is that it decodes or interprets the instruction in IR. So in the IR is just going to be a string of ones and zeros. The number of bits each instruction has just depends on the microprocessor you have, and basically how new it is. If it's a 64-bit microprocessor, you can have 64-bit instructions, 32-bit, 32-bit instructions. The first microprocessors in the example that's in the book were just 4-bit microprocessors, so the instructions were just 4 bits. But no matter the number of bits the instruction has, part of the TNC, part of the timing control circuitry, gives meaning to those zeros and ones. Okay, this goes back to something I talked about at the very beginning of the digital block, and that's in of themselves these zeros and ones are just voltage levels. It's the circuitry built around those zeros and ones, built around those voltage levels, that give the bits meaning. So, bits can have any meaning you want. We've seen, numerical meaning. We've seen alpha numerical character meaning. They can represent color, sound, and here they're representing an instruction. Okay, so it's this part of the circuitry inside the TNC gives the instruction meaning. Okay, the other thing that the TNC does, the main function of the TNC, is that it carries out the instruction. So it makes the instruction happen. It executes it. Okay, so makes instruction happen. And it does this by controlling the other hardware in the microprocessor. So for example, if the instruction was to add two numbers, where one number was in the accumulator and the other number was in a general purpose register, which is one of these registers B, C, D, E, well, the TNC would coordinate, would organize, would control all the other hardware to make that instruction happen. So some of the things that would have to occur is those two numbers would have to be transferred over to the ALU. ALU stands for arithmetic logic unit. So inside this circuitry is an adding circuit. So those two numbers to be added would be brought inside the ALU, added together. The result would then be put in the accumulator. And that's just a couple of the things that would have to happen in order for that instruction to be executed. And each thing that needs to occur for an instruction to be completed is called an event. Event. And depending on the instruction, there could be just a couple events or a dozen or so or more events that need to occur. Well, each event is going to occur on the edge of the CPU clock. Because just think about it. Most of what's inside this microprocessor are registers, and registers are made out of flip-flops, and these flip-flops are edge sensitive. A change can only take place on an edge. So anytime there's a transfer or an operation that takes place, it occurs on the edge of the clock. In between the edges, the data is being stored. So this is, a reason why CPU clock frequency is an important factor in processing speed, because the faster or the higher your frequency is, the closer these edges are together and the less time it takes to complete the events that execute the instruction. Now, CPU clock frequency is not the only major factor for processing speed, but like I said, it's one of the major ones. There are others that you can read about if you find any reputable computer book on PCs. Alright, so like I said, this was just a brief overview of a microprocessor, just some of the hardware. For some more details, take a look at that handout that's on PolyLearn, and that finishes 321. So I hope you enjoyed the course, and maybe I'll catch you in another course down the road somewhere.